Section 2.9, Applications of Probability. Number 1. A small town is considering whether to build a dog park. Randomly selected households were asked how many dogs they own. The frequency displays how many households had X number of dogs. Their data is summarized in the following table. Let's highlight some important key sentences in this example. Households were asked how many dogs they own. So picture somebody going around asking a person in a house how many dogs they own, right? So what would be an answer? In this data that we have, a common answer would be 0, 1, 2, 3, 4, 5 dogs. I'm looking at the number of dogs. And then it says the frequency displays how many households had X number of dogs. So it goes on to explain that X is used to show the number of dogs. Now let's come into the table. Remember, it's always very important to observe a table and understand the table before you try to answer any questions. This is called a frequency table. And it tells you the frequency, or how often or how many. Let's take a look at a point in this. If I'm looking over here at 5 and 14, remember, it's always really important to make yourself a sentence so that you understand what this table is about. So here comes my sentence. 14 households responded that they have 5 dogs. You think it's common to have 5 dogs? Not according to this frequency table, it's not that common. Out of all of the people they asked, only 14 people, or it's only 14 households said they had 5 dogs. But if you look a little bit on this end, where we're looking at no dogs, that's a lot more households. Okay, and then the last row is going to ask us for the probability of X dogs in a household. So I'm already observing a couple words, even though, I haven't been asked to do anything. Probability, I remember we did this in the last section, and then it involves the dogs in a household. Question A. Write a complete sentence that explains what the first values 0, 1491 represents in context. Ooh, okay, great. So we already put a sentence together. It was for the last point, and I'm going to come back and point out that this point that we wrote over here was 5, 14, 5 representing our number of dogs, or the X value, and 14 representing the number of households, or the frequency in this case. So over here, this point that's being given to us, 0, 1491, then we know that this is dogs and this is households. And you're ready to write a sentence. Let's do it. $1,491 households responded that they have, how many dogs? 0 dogs. So in fact, 0 dogs is a lot more common than 5 dogs. Let's use the table to evaluate n. And what is n? It is the sum of the frequencies. The question is, what is n? Right? Because it says evaluate n. And then now I'm reminding you, what is n? It's the sum of the frequencies, because that's what it's asking you for. Let's do it. What are we going to add? So a sum of frequencies is 1491 plus 425. Break out our calculator. $2,175. N is 2,175. We can write this a couple of ways. I feel that this is a sentence. We could also just say, you don't have to do all of these, okay? I'm just giving you examples of how to answer. N is equal to 2,175. You can also say the sum of frequencies is equal to 2,175. I think either the sentence or the number like this is more appropriate because in a little bit they're going to ask you to use N. So I don't want to associate it too much with the sum of frequencies, but rather with N. Part C. Write a complete sentence that explains what N in Part B represents. Oh, what is N? N is the sum of the frequencies, but even further in context, N is the sum of frequencies, and even further in the words of the problem, N is the total households that answered the survey. So mathematically, it's the sum of the frequencies. In context, it's the total households. Part D, use the table to evaluate this formula. Let me point out first that this formula should have a pair of parentheses. And so let's fix it before we start evaluating. We're going to multiply x times the frequency. And in order to do that, we need a set of parentheses. Right now, it does not have parentheses, so it tells us to do the sum of x just times f, and that would be overall one thing. So there's a big difference between having parentheses and not. So once again, this is a mistake. Let's go ahead and fix it. And then now let's read it. I find that students often don't read the symbols, and it also leads to them not understanding or misunderstanding. So this formula says the sum of, and then here it is. What's the sum? X times f. And then you're going to take all of this divided by n. So if you look at the words, if you look at the symbols, I feel that it's so much easier to calculate now with a little bit of words. So the first x value that we have is 0, and we're going to multiply it times f. And the f value corresponding to the 0 is 1,491. So it tells us that we're going to do the sum of, so I have plus because of the sum of, and then x times f. What x's are we picking? We are picking the whole table. So if you're looking back at this table, we're going to complete this whole thing with its pairs. So 0 with 1,491, 1 with its pair, and so on. Let's look back. Plus 1 times 425 plus 2 times 168 plus 3 times 48 plus 4 times 29 plus 5 times 14. And we're going to do this all over n. And we know what n is. N is 2,175. And we're ready for the calculator. Let's bring that up. and we're going to have 0 times 1,491. You should know that that should be 0, but we're taking care of everything on the calculator. And then 1 times 425, that should be 425. So we have 0 plus 425 plus 2 times 168 plus 3 times 48 4 times 29, and last one, 5 times 14. This is all over 2,175. Let's add these up. So I have 0 plus 425 plus 1,091, all divided by 2,175. Let's input that in our calculator. And we end up with a decimal. Now, looking back at the question, it does not inform us what to round to. So I'm going to use 4 places. 4 places always seems like a reasonable number because it doesn't feel like I left out too many numbers, like I'm chopping off too many things. So I'm going to the squiggly equal sign because I'm about to approximate. Remember, if I want to approximate to 4 decimal places, then I need to write down 5 so that I can follow my rounding rules. So here goes 1, 2, 3, 4, 5 decimal places. So if I'm going to do to the 4th place, and the 0 is where I look, these are my little eyeballs looking at that 0. So what's going to end up happening? The question is 0 5 or more? It is not. Therefore, the 6 stays the same. And our final approximated answer is 0.5016. Let's complete the last row in the table. It says recall that the probability of x, which is p of x, right? So it's saying probability of x, and then it's giving you the same thing. So these two are the same values, okay, or same words, is equal to the frequency divided by the number n. Write the probability values as a fraction, then change to a decimal rounded to the nearest 10,000th place. 10,000ths is 4 decimal places. We're going to do this by taking f divided by n. What is the first value we have? What's f? F is 1,491 divided by n, and n is the sum of frequencies, 2,175. So actually we can go through all of this and it's fairly simple. So let's do 425 divided by 2,175 and so on. And then now our goal is to convert it to a decimal rounded to the nearest 10,000th place. This is 4 decimal places. I'm going to use my calculator. So remember, I'm going to look at 5, number, the 5th number, and then round based on that. So it's 6855, and the last number is 1. So we're going to stay at 5. So it's going to be 6855. Beautiful. Next one. Remember, we're doing 4 places, so this is going to be 195, and then we have 40, so the 4 is going to stay a 4. 168 divided by 4 places. That's going to be 0, 7, 7. Then I have 2, 4. The 4 is less than 5, so this is going to stay 2. 0, 2, 2, 0, 6. The 6 is more than 5. This will go up 1. Remember, there's only staying at the same number or going up 1. There's no such thing as getting smaller. So we have 2, 9, 21, 75. We have 0.013333. So we're going to stay at 33. Last one. We have 0.0064.